Ow! Ow! Woo! Geometry, what's up? Let's do section 2 of chapter 6. It's on parallelograms. And there is a slew of information you know if you know something's a parallelogram. Okay? Basic definition of a parallelogram is you have opposite sides that are parallel. Okay, my drawing, who knows about that? But these should be parallel and these should be parallel. Okay? Once you have that, you know it's a parallelogram. And the book goes on, specifically lesson 2 here, goes on to tell you a bunch of things. And I'm just going to kind of list them, okay? Theorem 6.3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. This would be congruent with that, and this would be congruent with that. That's 6.3. 6.4, theorem 6.4 says if a quadrilateral is a parallelogram, then its opposite angles are congruent. This would be congruent with that. This would be congruent with that. 6.5. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Let's call this x and this y. X plus y is going to equal 180 degrees. If this was z, y plus z is going to equal 180 degrees. So anyway, I think that's self-explanatory. You get that. And the last one here on page 433 is 6.6. It says if a parallelogram has one right angle, then all 4 angles are going to be right angles. So let me try to draw that. If you know one of these is a right angle in a parallelogram, it's impossible to have these other ones not be. Think about it. The theorem we just did, 6.5, says that if this is 90 degrees, we know that this is 90 degrees. They have to add up to 180 degrees, right? If you know this one's 90 degrees, you know this one has to be 90 degrees because it has to add up to 180 degrees. And lastly, you know this one for the same reason. Okay? So one right angle makes the whole thing have right angles. And what would that be called? A rectangle. Okay? All right. I think we can kind of, the rest of this chapter up until page 435, it then starts talking about diagonals. And let me kind of make this a little cleaner. But no matter what kind of no matter what kind of parallelogram you have, when you draw the diagonals for it, this is 6.7. Theorem 6.7 says when you draw the diagonals, they're going to bisect each other. This line segment, we'll call this A, B, C, and D. So line segment AC is perfectly divided in half by BD and vice versa. They bisect each other. Furthermore, if you just draw one, any diagonal of a parallelogram divides this into two. It's 6.8. It says if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. So ABC is congruent to CDA. And even if this thing looks a little funky, even if it was a crazy shaped parallelogram, whoa, too far. Okay, if that's a parallelogram, if I divide it this way, those two are congruent. If I divide it this way, then the other two would have been congruent, okay? All right, so with that amount of theorems, you know that they're going to ask you to do some proofs, but you have lots of tools at your disposal, okay? So look in your toolbox, pick out the best theorems, and use them. Okay, I think that's it. Cheers.